So, good afternoon, everyone. Myself is Dr. Ajit Kumar, and I'm faculty in the Department of PSEN at the Presidency University. So, in the last class, we were discussing about the memory interfacing. We'll continue this part third of our memory interfacing. Fine. So, here we have two types of memory. Okay, first of all, let us assume that this is your 8051 microcontroller, which I've shown here. This is your RAM, and this is the ROM. Fine. So here we have two types of memory. One is called the internal memory, and another one is called external memory. Okay, the internal memory is memory chip. Okay, is also called on-chip memory. On-chip memory. On-chip memory means the memory chip is inside the microcontroller 8051. Okay, so in this case also we have two types. Okay, on-chip memory is also of two types. That is on-chip RAM, on-chip ROM, and on-chip RAM. Okay. Similarly, another is external memory. External memory. Now the external memory is also that memory which is called off-chip memory. Off-chip memory. So this one, again, this off-chip memory is also of two types. One is called off-chip off. Okay, one is called off-chip RAM or off-chip ROM, and another one is called off-chip RAM. Okay, so here we have broadly two types of memory. One is called internal memory, external memory. Internal memory is also on-chip memory, okay, on-chip memory and of on-chip ROM and on-chip RAM. Similarly, we have second one is external memory, in which we have again on-chip ROM and off-chip ROM. Okay, so here I have shown this RAM, which is called off-chip ROM. That is external RAM. Okay, so this one is external RAM. This one is called external RAM. Okay, the capacity could be anything. Right now, I'm not going to talk about this one. Then we have another two, which is called on-chip memory and on-chip. Sorry, that is on-chip RAM and on-chip ROM. So let us say that this is your on-chip RAM. Okay, similarly, let us consider this as on-chip ROM. Okay, on-chip ROM. So why they are called on-chip ROM? Because inside microcontroller 8051 only they are embedded. Okay, that is why the concept of microcontroller comes. Fine. Now how they are interfaced? Okay, I mean when we are talking that about interfacing means actually we are talking about the external memory. Okay, we will not talk about the internal memory right now. So here interfacing is actually concerned with this external, okay, external memory. Fine. So external memory means this external ROM and external RAM. Fine. So now you have to understand two connections here. Okay. In 8051, we have a pin which is called RD. Okay. I'll show you this RD, and so I'll show you this pin RD. Okay, it is active low. Then we have WR. Right. So this RD means it is read. This WR means write. So these pins are actually connected with the RAM. Okay, uh, like this. Fine. So these pins are used to do read and write operation with RAM, because you know the with RAM we can do read and write both operations. However, with ROM we can only do read operations. Only we can do read operations. Fine. So if the process microcontroller wants to read something, then it is going to use this RD pin. Okay, and this RD pin of microcontroller is connected with OE pin, output enable pin. Okay, this is O means output, E means enable, and this WR pin of microcontroller is connected with write enable pin, WE pin of your RAM. Fine. Similarly, when the microcontroller wants to perform read operation with the ROM, then there is a pin which is called PSEN. Okay, this PSEN means program store enable. Okay, program store enable. PSEN means program store enable. This PSEN pin of microcontroller is connected with the ROM. Okay, in the ROM, it is connected with OEP, output enable pin of the ROM. Okay, so when the microcontroller wants to read, now first, try to understand this ROM is also called program memory. Okay, this is also called program memory. Program memory. This on-chip ROM is also called program memory. They are called program memory because they contains the program that we write. Okay, and this on-chip RAM is used to store data. Okay, it is used to store the data so that temporary time. Well, one more thing, this is called program memory. This is called program memory. This external RAM is called data memory. So you have to understand these connections. Okay, that when the microcontroller wants to do read and write operation with the RAM, then this RD and WR pin is used. Okay, and when the microcontroller wants to read any instruction or the program from this external ROM, then this PSEN pin, this is also active low pin. Okay, this PSEN pin is connected with OE pin of your ROM. Okay. Now, one more pin is there to that will actually decide that which I mean, the microcontroller is using on-chip memory to access the data or on-chip memory to access the data, which I had already explained. Okay, that is called EA. Okay, enable. Okay, okay, EA. So this is actually used to decide. Okay, this how it is going to decide if. So I write this in very short. If EA is connected to the ground or binary zero, so in that case, external external memory, that is off-chip memory, is being accessed by your microcontroller. Okay. However, this is the first one. And second one is if EA is okay is connected to binary one or you can say VCC, then internal memory. Okay, internal memory is accessed by the microcontroller. Because this is the designer has designed this in this way. Okay, so let's say we are talking about the external memory RAM and ROM. So this EA will be actually connected to ground. Okay, connected to ground this way. So here it is GND ground. Okay, that is EA is actually zero. Okay, so when this pin EA is connected to the ground terminal, then external memory will be used by the microcontroller. Okay. And similarly, if this EA is connected to VCC, some 5-volt source, okay, then this internal memory chip will be accessed by the microcontroller. Okay, this is how it is differentiated between external memory and internal memory operation. Okay. So having learned having learned all these things, okay, one more thing I need to show here, which is called latch. Okay, here we have one more circuit. I'll show you. There is a latch here. Okay, so this latch is a temporary storage device. Now, where this latch came and why this latch is there, so just recall, you people might have studied about the D latch. Okay, D latch you people studied. So in the D latch, what happens is this is your DLAT that you may prepare from this SR latch. Okay, that is when we connect S and R both into, okay, then actually it becomes your DLAT. Okay, uh, that is actually connected to the notebook. Okay, that is, you know that this input pin is S and the same is connected with the NAND gate, and then it's called R, and then this input is called D. Right? So you know that if, okay, here the Q is the output, so if you know that if D is 0, then the latch output will be 0, and if D is 1, okay, D is 1, then the latch output will be 1. That is already studied in the digital electronics. Okay. So the function of this latch is used to store the input values. Okay, the function of the latch input values temporarily. You also know that we provide here to enable this latch. Okay, to enable this latch, we connect here this kind of signal. Okay, that is either this kind of signal, high, okay, signal. Okay, so here I give this uh, high pulse signal, this kind of signal, okay, which is high here. You can see it is high for this one, it is low for this one. Okay. Here it is low, and here it is the high. So I give a high pulse, okay, not like this. Here I give this high pulse signal, okay, high pulse will be given. So at that moment only, if you are giving here D is 0, okay, so if you are giving D 0, and at the same time this uh, external pulse signal is high, then only your Q will be 0. Okay, so this is to enable the latch. Okay, this high pulse is to enable the latch. This also, I hope you people are studying the digital electronics subject. So what is happening is why this latch concept came here is because it is used as storage device, temporary storage device. Now why this latch is coming is because I'll show you a small discussion. Recall that let's say this is your microcontroller, this is your, let's say, external RAM, okay, external RAM. So in this one, we have they I know that they are connected with the buses. Okay. So one more thing is that let's say I have address bus, data bus security. So let's say this is your address bus, okay, address bus, and let's say this is your data bus. Okay, this is your data bus, and then we know also that there is a control bus. Okay. So suppose that in this memory location some data is there, and let's assume that the address of that memory location is 001H. Yes, similarly the video address is 00H. So let's say that this data has to be read by the processor. So you know that if you remember, I already told you what is read and write. So it is just like your brain. Okay, you have to understand this read and write operation from your microprocessor or microcontroller context. Okay, so read means that this is your notes. Okay, this notes used to read, and you read in the before the exam. Okay, before the exam, you read the notes. Okay, and in the exam, you go and write these notes. Sorry, these answers. Okay, so in the exam. Okay, so this brain. Okay, this brain is just like your processor CPU. Okay, and this nodes, okay, this nodes is something like input device, let's say keyboard, and uh, this this is like your monitor where your output is being displayed. Okay, so what it is doing, just like the brain is reading the notes, no, and then it is writing it, and that, okay, it in the notebook. Okay, that is called scripts of your exam. So when it is writing, it is actually storing by writing. Okay, and when it is accessing the data, it is doing it by reading. Okay, that's reading. Okay, so same way the microcontroller I will, okay, either read the data, okay, read the data, okay, in from the memory chip. This data will be brought inside the microcontroller. Okay, so when you bring the data, when the microcontroller or microprocessor bring the data from the memory chip, or let's say internal device like keyboard. Okay, you know, keyboard with when you enter any button, something like that, that signal goes into the microcontroller. Okay. Or then it is a read operation. Okay, or the microcontroller may do another thing which is called write. Okay, so write means when the microcontroller wants to store something, okay, in the memory data here. Okay, so here that new data will be written by the microcontroller, or this is done by write operation. Okay. Or it may also perform with the output device like monitor. So after processing the out, let's say you have written a program to add two numbers. So the processor will add, or microcontroller will add that two numbers, and it will display the sum here in the monitor screen. So this is done by write operation. So you have to understand that read and write is from the context of microcontroller or microprocessor. When the microcontroller wants to access the data from the input device, okay, then it is done by the read operation. When it is going to store something in the output device, then it is done by the write operation. Similarly, the same concept is applied with the external memory chip, okay, or internal memory chip also. When the processor wants to access the data, it is done through the read operation, and when it wants to store something, then it is called write operation. Fine. So the question is, suppose that this data is there, okay, and this data has to be brought inside. Okay, let's say the microcontroller is going to do read operation. So read means this data has to be brought here. Okay, this data has to be brought in the microcontroller. Now you know what is the step here. First of all, this address 0001 will be loaded on the address bus by the microcontroller 0001, and this is step 1. In step 2, it will send a memory read control signal to the RD pin. Here RD pin is there. Okay. So through that RD pin, it is going to send a read signal. Okay. This is read signal. So after getting this read signal, the microcontroller will know that the memory chip will know that the microcontroller wants to read the data which is stored in this address 1H. So whatever data is there in the form of zeros and ones will be loaded on the data bus. Okay, so that data will be loaded on the data bus. That is step 3, and this was the step 2. Okay, and then that data will be brought inside the processor. But what is happening now? Here, if you see the practical microcontroller, okay, has 40 pins. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, 20 pins on the left side and 20 pins in the right side. Okay. Now recall the address bus of 8051. Okay, this is 8051 microcontroller. Address bus size is 16 bit and data bus size is 8 bit. So ideally, if the microcontroller is going to utilize the pins, okay, for these pins for buses, okay. So in that case, 16 pins will be used for the address bus, and then 8 pins, okay, 8 pins will be used for a data bus. So this is not effective utilization because there are total 40 pins. Out of 40 pins, you have given 16 pins for the address bus, 8 pins for the data bus. Okay, this is a poor utilization of the source. Okay, so what we do is we employ the concept of multiplex. Okay, so in the multiplexing, what is done is the same pins are used The same pins are used for address bus as well as data bus. So here we have 40 pins. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 pins are there. So with external devices. With external devices, the microcontroller has to communicate. Okay. So what we do is the microcontroller cannot communicate with those devices directly because these external devices operate on different voltages, okay, and different speeds. Okay, different speeds, uh, for example, the mouse, okay, or the keyboard, okay. Each one of these devices are operating on the different voltages and different speeds. So this microcontroller is actually unable to handle the different devices because they are operating at different speed, different voltages. So for this purpose, there is something called ports. Okay, so for example, in 806, we use a different IC. Okay, those ICs are actually used for the compatibility purpose. Okay, those ICs are actually being used as interfacing device. Okay, those ICs we use here, special ICs, okay, which is called IO ports. Okay, these IO ports are used for compatibility. Compatibility because because what is happening, the different external devices, let's say this is operating on a plus 5 volt, this is operating on 6 volt, okay, this is operating at some different speeds, okay, this is operating on different speeds. So this IC act as intermediate device, interfacing device. This interfacing device is called IO ports, which will accept the data from the external device, give this data will be provided to the 8051, or it will accept the data from the microcontroller and give data to the external device. So this is called your IO ports. Now, this was the case with the microprocessor. In the microcontroller, this IC is already there, okay, inside the 8051 microcontroller. You don't need this external IC, okay. So there are total 4 ports here. There are 4 ports in 8051 microcontroller. That is port 0, port 1, port 2, okay, port 3. So these are all these ports are actually 8 pins. 8 pins. Okay, so this, for example, this one, two, three. Okay, let me now erase this because uh, these are the external IC. Now these IO ports are actually inbuilt in microcontroller, so I'll not show them here. Okay, uh, I'll show them inside your microcontroller itself. Okay. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8. This is called port 0. This is called port 0. This is used to interface with the external devices. Okay. Similarly, we have here 1, 2, 3, 4, 5, 6, 7, 8. This 8 pins is called port 2. Okay, similarly this side 1, 2, 3, 4, 5, 6, 7, 8. These 8 pins are called port 3. Similarly, we have 1, 2, 3, 4, 5, 6, 7, 8. These 8 pins are called port 4. So total there are port 3. 0, sorry, 0, 2, then there is 1, 3. So this is 1 and this is 3. So port 1, okay, and port 3. Fine. Now what is happening in the port? Now this port 0 is also interfaced with the buses. Okay, this is interfaced with uh, address bus. Okay, right here. This port 0 is also multiplexed with address bus, address bus, and data bus. So in the short, they are called trading. Fine. So this pin, is called AB0. That is A naught pin of address and D naught pin of data. Both are now being utilized by this pin. Okay, that is called multiplexing. Multiplex. Multiplex. Okay, similarly, this pin is multiplexed with AD1. That is A1 pins of your address and D1 pin of your data. Okay, this is also multiplexed. Similarly, this one is AD2. This, okay, like this AD7. All these are multiplexed. Okay, that is address bus, data bus are multiplexed. So what we have done is in the 8 pins we have utilized A naught to A7 and we have also utilized D naught to D7. If I would not have done this multiplexing, then total 16 pins might have been wasted. Instead, I have utilized only 8 pins. Similarly, port 2 is actually multiplexed with higher order bus because we know that the total bus size is A0 to A15. Okay. And data bus is 8 bit, so D0 to D7. Okay, so this is over. This is over. Okay, but this is not over. Okay, this is incomplete. So to make it complete, here comes A8 bit. Okay, then comes A9 bit, then A10 bit. Like this, it will go up to A15 bit. Okay, so these are called higher order bus. Okay, higher order bus, and here they are called lower order bus. This A0 to A7 is called lower order bus. Okay. Now, see what is happening. Uh, because it has to communicate, okay, this microcontroller has to communicate with memory chip or other devices. So let's say here we have this my memory chip. Okay, let us assume that this is your memory chip. External memory, that is, let's say RAM only. External memory RAM. Okay, now let's suppose that in this location again there is data. Okay, let's assume that this is 001 address. Okay, so this is the address, and in this address, this data is here. And again, I know that this memory chip will be connected with this address plus data bus. Okay, so what is happening? Recall in step one, the address will be loaded on address bus. Address bus. Fine. And we know that this address bus, I mean, what is the size of this address? Is 16 bit, right? Because you know this is hexadecimal, so it is 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4, and this one is written as 0001. So this is your address. So now this 16-bit address will be loaded here like this in A0 0, in A1 0, like this up to. So this is let's we have to start something. A0, A1, A2, and so on. That is A. So from A0 to A7, from here to here. So A0 is actually 1. So how about here 1? Then A1 is 0. Then 0, 0, 0, 0, 0, 0, 0, 0. Okay. All these A15 up to A50, all these will be loaded in their address buses. Okay. Now this was done in step 1. In step 2, you know that from RDP, okay, from RDP, so memory read signal, MEMR will be sent to the stack. Will be sent to this mouse. Okay, so this is fine. Now step 3 is important. Step 3, what is your data? data from memory address 0001H will be loaded on data bus. But this data bus, which was D0 to D7, is carrying address, in step 1. Do you remember this? See here, this one, okay, this one is, okay, this one, D0 to, actually we have used here A0, okay, so let us say A0. Okay, so A0 to A7 was carrying your address in step 1. But the same pin is also containing D0 to D7, which is supposed to carry the data in step 3. Now, is it possible? Can it be possible that suppose that this is your road, okay, let's say that this is your road, and this side data is, let's say, buses are going. Okay, let us assume that this is a two-lane road. So in the two-lane road, I know that one bus will go like this buses will be going like this. Now, is it possible that the same in the opposite direction bus will come? Okay, it is something that is quite obvious. It is not possible. Okay, in the same you can say route, either it will go or it will come. Okay, in both ways, it is not possible. Okay, so you know that in D naught, we have this D naught bit, we have transmitted the address bus in step 1, but in the step 3, the same bus is going to be used for the data collection from the memory. So what we will do is we have to use here something which is called latch. Okay, so how it does is, see, what I will do is, here we have this microcontroller. Okay. Here I'm going to use this latch. This latch you will have to use here 8-bit latch. 8-bit latch. So basically you know that one 8-bit latch we cannot have. Okay, we have here 1-bit latch in which we are giving D. Okay, and then we are getting the output. So you can use here total like 8 latches. Okay, like this 1, 2, 3, 4, 5. So I mean I'm not going in that much detail, but let us assume that it is 8-bit latch. What we will do is here, see the diagram from port 0. Okay, so again from that, and I'll have to draw here. I will draw this port 1, 2, 3, 4, 5, 6, 7, 8, and I'll say this is port 0. And this was AD0, AD1, AD2, like this it is AD7. What I'll do is, okay, this will be acting as input to this latch. Fine. So whatever address you have assigned will become input for this latch. What was the address? 100000000. This was the address. And at the output, again, you are going to get the address one. Because you know this is like D latch in which D is 0, then the output is 0. If D is 1, okay, then the output is 1. So whatever is the input, same will be the output. Okay, that is 1, 0, 0, 0, 0. So 1, 2, 3, 4, 5, 6, 7. Okay. Now what is happening? Here we have given AD0. Okay, that is one. It was multiplexed. Okay, but what is here is A0 only. A0, A1, A2, A3. Okay, so in step 1, when you have transmitted the address, you transmit the address and get it stored at the output of the latch, and this from the output of the latch, this address will go to your external RAM. Okay, so all these will become input to this one. Now recall this. Okay, these buses are now free. The buses which is connected from port 0 to this latch are now free to carry to carry. Okay, so now right here and right here. These buses are free to carry data because at the output of the latch we have stored the address and that is given to the external RAM. Okay. However, to enable this latch, I mean to store the output, okay, to store the input, there is a pin from 805 or microcontroller that is called ALE. Okay, this will send a high pulse signal that is binary one, okay, to this latch to enable the latch. Until unless this latch is not enabled, the output will not be same as input. Means this latch is not going to store the input value. Okay. So this ALE pin inside the microcontroller is used to enable this latch. Okay. And once these buses now are free to carry the data, so what is happening here? These buses, okay, that I'm now going to show it them as D naught. This is non-overlapping. So this is now D naught. Same D naught bus will be connected with D naught pins of your RAM. Similarly, this D1 will be connected with the input pins of D1. Likewise, this last one, that is D7, okay, will be connected with D7 pin of your RAM, and they will be used to carry the data. And you know it is bidirectional, so you can store it like this, okay, like this, both ways, like this. Okay, so the purpose of this latch is to just demultiplex the address and data. Okay, once it has been demultiplexed, then you can use that bus to carry the data. Okay, the data can go in both way, either this way or this way. Okay, so in this direction, when it is going, it is for the right operation, and if the data is coming in this direction, then it is for the read operation. Okay, so if you have understood this concept of latch, then I will come back to our main diagram here. Okay, where I have shown this latch here. Okay, so let me draw this latch in red color so that it is not mixed. So let's say this is your latch. Okay, now what I will do is from port 0, I will connect here AD 0 to AD7 as the input to this latch, and the output of this latch will go as A0 to A7 for this RAM, and the same bus is also okay. We don't have separate address bus, data bus for this RAM and ROM. Okay, same bus is used. Otherwise, it will become very bulky. Okay, so the designer has designed this in this way so that it don't become bulky. So A0 to A7. Suppose that the microcontroller wants to read from this or ROM. Okay, then I mean the output of this latch will be available to this ROM. If the microcontroller wants to do read and write with this RAM, so in that case, the output of this latch will be input to this RAM. Okay, this is how the same bus is utilized. Okay, and this PSEN pin, this PSEN pin is of course there and connected with output enable. It is important. Okay, so you have to label this also. Okay, so this latch input AD0 to AD7, output is A0 to A7, and then we have A8. Okay, now there is another one which is called port 2 from where A8 to A15 is there. So that will be connected direct. exactly like this. A8 to A15, and the same bus is connected here also. The diagram is little bit complex that you have to understand. So the same bus, same bus is labeled as A8, and this one A15. Okay, this is how this external RAM and ROMs are interfaced. Okay. Uh, so having understood this connection, now we are in a situation to uh, understand few numerical examples. Fine. Okay. So suppose here I just discuss one numerical example. Let's say with the questions or the numerical will come something like this. With neat diagram, show the interfacing, show the interfacing of 8051 with 8 kilobytes of 8 kilobytes of RAM and 8 kilobytes of ROM. Okay, like this the question comes. Fine. So what you have to do is first of all just make here uh, microprocessor. Fine. Make one microprocessor something like this, and another one as RAM, and this is your ROM. Say this is 8051, this is your RAM, which is 8 kilobytes, external RAM, and this is your external ROM, which is also 8 bytes. Fine. Now, when it is asking for interfacing particular capacity of RAM and ROM, it is actually asking to show you or find the range of address. It is indirectly asking to find the range of address and the address decoder circuit, something like that. Okay. So here, now if you recall in the last class, we have discussed that where unused address lanes are being used. Okay, so here also we'll see, because I know that 8051 microcontroller is able to access 64 kilobytes of maximum memory chip capacity. Okay, however, we have only 8 KB of RAM, 8 KB of ROM. Okay, so in that case, we will see that there will be some unutilized address bus, okay, and that unutilized address bus should be used for the chip selection. Okay, so in here for this RAM, we have one chip selection CSP. Okay, and here also for the ROM, we have CSP, which is chip selection. Because you know, this microcontroller is going to access either RAM or ROM. At the same time, it is not going to access both this one. Okay, just take my example. I'm teaching in this classroom. I cannot teach at the same time in another classroom. Okay, so I cannot access the both rooms, okay, at the same time, either this room or that. In the same manner, this microcontroller can access either RAM or this ROM. Okay, so for this purpose, this chip selection pin is there. Okay, so whenever this RAM is enabled, okay, when this RAM is enabled, at that time this will be disabled. Okay. Or when this is enabled, okay, when this is disabled, at that time this will be enabled. So this is how it is going to work. Okay, so we have to understand this. Okay, so let us try to find the number of buses required for this. Okay, RAM, this RAM, and this ROM. So you know how to find the number of buses required. You have to simply write 8 KB. So 8 means 8 is fine. Kilo means 1024 bits. This also 8 means 8 and K means 1024. These many bits are there. Now this total bits has to be written in the power of 2. So this 8 is written as 2 power 3. Okay, and this 1024 is 2 power 10, so you will get 2 power 13. Now this 13 is your address bus size. Okay, this 13 is address bus size. Similarly, here also you will get 2 power 13. So here also you will get this 13 as address bus size. So what is the meaning of 13-bit address bus? 13-bit address bus means A0 to A12, A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, A13, A14, A15. So because it is saying 13 bit, so 13 bit means from A0 to A12 here. So this 13 bits is actually required required by both RAM and ROM. So then what about this unutilized? These are unutilized. Unutilized. Utilized. This unutilized will be used for address decoder. Address decoder. Okay, see here. What I'll do is this 13 bits. Okay, these 13 bits will be directly connected. This will be directly connected from microcontroller to the RAM and ROM. Okay, so you make direct connection here. Directly connected to microcontroller. Okay. So what I'll do is just here I'm going to draw a naught. Okay. So recall, let us start from this side. Okay. So you know this is AD0. Okay. Then it will go up to AD8, AD7. Okay, AD0 to AD7. And I know that this is port 0 where the multiplexing is done. Similarly, we have okay, A8 to A, let me draw properly A8, A9, A10, A11, A12. Then the unutilized I will show in the different color. That is A13, A14, A15. These are unutilized. Okay, now what I'll do is this AD0 to AD7, you know they will be connected with the latch. So you have to draw one latch here. The output of this latch will be connected with CS pin has to be removed. So one thing, I'm removing the CS pin from here. I'll make that CS pin somewhere else. Okay. So this is like this. This is a naught because you know at the output of the latch you will get address only, and this will be A7. And intermediate is there. Fine. Now similarly A8. The A8 will be directly connected to this one. A9 also will be directly connected to this one. Similarly, A10, A11, A12. All these will be directly connected. Okay. 10, 11, 12. You bring this buses, okay. You bring this buses. Say, as I said, the same bus will be connected to the ROM also. So you have to show like this A naught to this one A7. Okay. So here A0 to A7s are directly connected with ROM also and with RAM also. Similarly, A8 is also connected directly. So you will bring, suppose that I have this, okay. So this one is about, okay, and coming here, A8 and this one, okay, intermediate values also here and coming here like this, A12. They are directly connected. Fine. Now, very important concept come here that what to do with this unutilized A13, A14, A15. So they will be used as address decoder circuit. Okay, we will utilize them as address decoder circuit. So what I will do is, okay, what I will do, I'm going to make, I need space here. What I will do I need space here. Okay, no problem. This is actually I wanted to show here something called, okay, no problem. Okay, this is eraser. Fine, no problem. Let this arrow box be there. So what I'll do is I'll show the decoder circuit. So what I'll do is here I'm going to use let's say OR gate as decoder circuit. So this the input I'm going to draw two OR gates. Okay, the output of both OR gates, okay, will be utilized for the chip selection. Okay, so this is OR gate. This is OR gate. This OR gate is for RAM. Okay, and this OR gate is for the ROM. Connect. Okay, the input. Now, so you know that the output of this ROM is going to be connected as input for the CSP. Okay, so I'll write here CS. And let's say here also, for that purpose, I'll draw it separately. So what I'll do is this 13, connect the 13 here. This 14 you connect as input to this OR gate. This 15 you connect as input to this OR gate. Now, if all these inputs are 0, 0, then you know the output of OR gate will be 0. So at that time, this 0 will be enabling this RAM. Okay, so this will be enabled. Now, when this has been enabled, at that time, this has to be disabled. Okay, at that time, this should not be enabled. Okay, so okay, let us connect this output of or gate to the CSP of your ROM. Okay, now at that time, this should be disabled. So how we can disable this? Okay, so what I'll do is I'm going to connect the pin number that is A13. Okay, so you bring the same 13 here. Okay, okay, connect one node. So when A13 was 0, okay, when A13 was 0, the output of this node will become 1. And you know that if any one of the input is 1, then this will become 1. And so here 1 will come, and so this will be disabled. Okay, see, now the rest 14, 15, okay, you can connect directly. No need of any node because I know if any one of the input is 1, then the output is 1. So this will be 0, this will be still 0. Okay. So this is how you can disable this one. Then what about the vice versa? Suppose that you want to disable this one, disable this, and you want to enable this. If you want to enable this, then our 0 should be there. Okay, the 0 should be at the output of OR gate. Now, A15 should be 0, A14 should be 0, but this input should be 0. Okay, so this input should be 0. Now, if this input is supposed to be 0, then A13 is supposed to be binary 1. Okay, so in that case, you have to give A13 as 1, A14 as 0, A15 as 0 to enable ROM. To enable ROM. Okay. And if you want to enable the RAM, so in that case, A13 should be 0, A14 should be 0, A15 should be 0 to enable RAM. Okay, this is how it is going to decide the range of address for both ROM and RAM. Okay, so we will see here that what is the range of address. Okay, so I'll write final answer. Okay, that is range of address. One more thing, key connection I missed here. Okay, that is, if you recall, I said that there is RD, okay, the RD pin, and then we have WR pin. So this RD pin will be connected, okay, or this RD pin, because RD and WR is supposed to be connected with RAM. Okay, so I'll connect this RD pin with OE pin of RAM and this WR pin of your microcontroller with write enable pin of RAM. Okay. Now this there is another one which is called PSEN. Okay, so here I should show this PSEN. Yes, one thing. I'll show PSEN here. So let us take one good thing. This I'll show dark blue. So I'll show here PSEN. PSEN. Okay. So this PSEN will be coming as input here. Okay. Input here as to the OEP of your ROM. Okay. So this is now complete connection. Okay. You can show this simply. You go and do like this. Connect this here. Connect like this. Okay, with OE pin of your ROM. Now this connection is fine. Okay, now connection is fine. So this is the diagram that you have to show. Okay, these are called address decoder circuit. These are called address decoder circuit. And now the final answer is I'm going to write the range of address. So what I'll do is I'll start from here. Let's say higher address A15, then A14, then 13, then 12, then 11, then A9, A8, A7, 6, 5, 4, 3, 2, 1, A0. So let me finish quickly because battery is running out here. So you know that 8 not to 812 were directly connected. So segregate it into two parts. Okay. And then this portion, okay, this portion is for the RAM and this portion is for the ROM. Now, if you recall, these wires A0 to A13s are directly connected with the RAM and ROM. So for the starting address SA and for the end address EA, this A0 to A12 will be 0. Okay, with the address lines which are directly connected, those will vary from all the zeros to all the ones. Okay, like this, fine. So this is for the starting address and for the end address also there will be 0 only, like this. Okay. So we'll be putting 00 from A0 to A12 as starting address and end address. Okay. Intermediate address is not very important here. Fine. Now, what about this side, which is unutilized? They are actually connected to they are utilized as address decoder circuit. Address decoder circuit, and we have seen to enable the RAM, what was the A13, A14, 15 value? Here we have seen. So we have seen this A13, A14, A15, this should be 0. So I'll write here as 0. Okay, 0, 0, 0. Okay, for the starting address, for the end address also, they should be fixed to 0. So these are fixed. They will not change, okay, because they are going to enable the RAM. Okay. Similarly, for the RAM, now what is the this is in hexadecimal, so you have to just compute it from by combining 4 bits. This 4 zeros, this 40, this 40, and this 40. So it is actually 1, 2, 3, 4 H. Okay, that is 4. And this is also 1, 2, 3, 4 H. So the start. No. I was saying correct. Here I wrote 00. These values are not 0, but they are 1. Sorry for this mistake. So here it will be 1, 1, 1, 1. End address is also always 1. So we'll substitute here 1, 1, 1. And then you see here this 0001 is 1. This 41 is F. This 41 is F. This 41 is F. So I will write here quickly. I will write here 1, 1 F F F F. This is the end address and this is the starting address. So this is the range address for the RAM. Okay. Now come back to the ROM. Okay, let us say this is starting address. So I write here SA starting address for the ROM and end address for the ROM. Now this side for the starting address again I will say that this A0 to A12 will be 01. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So A0 to A12 will be 0. This is for the starting address. And what about the end address? All will be 1. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Okay. So like this. Okay, now it's not over. Now to enable the ROM, if we want to enable the ROM, so what is the value of A13, A14? So you have seen A13 should be 1, A14, 15 should be 0, 0. Okay, so this will be substituted here. So substitute, fix this one, A13 1, A14 0, A15 0. This will be fixed, whether it is starting address or end address. So if I get 1, 0, okay, this is starting dot. So this is 0. Now in hexadecimal, this is 0010, that is 2, this is 0, this is 0, this is 0. So I this is 2000 H starting address and end address is 001, that is I think 00011 is 3. So I write 3 and then F. So this is 3 F F H. Okay, so what I got as the range of address? I for the RAM, range of address is 000H to 1FF and H, and for the ROM, I got range of address as 000H to 2, sorry, not 0, it's 2, it's 200. So 200 was to this 3FFF. So it is 3FFFH. Okay, this is the answer. So they will ask the range of address. As from the range of address, they will ask you to draw the circuit. So for this circuit, this address decoder circuit is very important. So we'll stop here. We'll meet in the next class with few more numerical examples. So thank you.